Okay guys, today I'm going to be making my first video where I kind of read through the notes and try to explain them as you guys fill them in. I just want you to know I do have to go a little quick because I have a 10-minute limit on these videos. So if you ever need to take it slow, just pause the video, rewind it, watch it over again. So thus far in this chapter, you guys have learned how to convert between moles and particles and moles and mass, like grams. Today I want to go over how to convert between moles and a volume of a gas. If you guys remember, the guy who came up with the concept of the mole was called Avogadro. He determined that if you took equal volumes of any gas, didn't matter what gas it was, and you put them at the same temperature and pressure, they always contain the exact same number of particles, same number of atoms/molecules. Now, the reason being is that even though these gases could be different sizes or have different masses, which they almost always do, the particles and gases are so far spread apart, it doesn't matter. So even though that they have different sizes, different masses, because they're so far apart, they still occupy the same volume. Now, this isn't true for liquids or solids, but it is true for gases. Now, you can change the volume of a gas by changing its temperature or its pressure. So because of this, whenever we do gas problems, which we may get to later in the year, we always talk about gases at a standard temperature and pressure, which we call the STP. It's just so that when we're comparing one gas to another, we can use the same temperature and pressure because, as we just said, at the same temperature and pressure, they have the same volume. Now, what is standard temperature and pressure? The standard temperature is 0 degrees Celsius, which, remember, we're using the SI units in science. In America, we would call that 32 degrees Fahrenheit. The standard pressure is called 1 atmosphere, which we abbreviate ATM. That means the amount of pressure the atmosphere is pushing on you if you were standing at sea level. Like if you were standing at the beach in New Jersey, you would be at 1 atmosphere. In America, we'd call that 14.7 psi. Okay, so at STP, 1 mole of any gas, which if you guys remember was 6.02 times 10 to the 23rd particles, it will always occupy the exact same volume, and that volume is 22.4 liters. Okay, so because 1 mole of any gas occupies that volume, we call it the molar volume. So 1 mole of any gas always equals 22.4 liters. Okay, so now let's try some problems where we convert between moles to liters. Okay, so this is going to be our basic setup where we start with moles in the top left block, and you can see in the top right block, we are using that conversion factor, 22.4 liters per 1 mole of that gas. X in this setup represents whatever type of particle we're talking about. Okay, so I highly suggest you guys always use this roadmap that I gave you guys. We're specifically looking at the top quadrant where it says volume of gas, and you can see it's connected to the mole red circle in the middle. We're using those two conversion factors for these types of problems. Okay, so example 1, determine the volume of 0.6 moles of sulfur dioxide gas at STP. Okay, so we always start by putting the unit that they give you, 0.62 moles or 0.6 moles of SO2 in the top left block. And now, remember, the bottom right block always has to have the same unit as the top left block. Okay, so in that bottom right block, I'm going to put 1 mole of SO2, and then the unit we're trying to solve for, which in this case is the volume in liters of sulfur dioxide, goes in the top right block. And that's where that conversion factor comes in, 22.4 liters per 1 mole. So now you just pull your calculator, multiply the two numbers, and you get 13.44 liters of sulfur dioxide. Okay, the next couple examples are the exact same thing except for the first block. So we're going to start with 32 moles of carbon dioxide. Again, 1 mole of carbon dioxide goes in the bottom right, and 22.4 liters of carbon dioxide goes in the top right. Okay, so you can see the moles of carbon dioxide cancel out, and we're left with just liters. So 32 times 22.4, and you get the answer of 716.8 liters of carbon dioxide. Okay, one more example, 4.9 moles of hydrogen gas. Again, the same thing. We put the same conversion factor in there. Then we multiply 4.9 times 22.4, and we get an answer of 109.76 liters of hydrogen. Okay, now lastly, let's try the reverse, where we convert between from volume to moles. Okay, so it's going to be the exact same thing, except you can see the second block we have inverted. The 22.4 liters is now on the bottom, and the 1 mole is on top. Okay, so the first problem